Problem solution approach phrases for EP patents. Clear, tested English. Welcome. In this micro lesson, we'll master the problem solution approach, PSA, used in European patent practice. You'll learn how to present your case with precise phrases at each PSA step, so examiners can follow your logic effortlessly. We'll focus on making claims, technical effects, and advantages crystal clear. No fluff, no marketing. By the end, you'll have a repeatable structure to argue inventive step, from identifying the closest prior art, to defining the objective technical problem, to proving non-obviousness with solid evidence. Let's build persuasive professional prose that stands up under scrutiny. Start by naming the best starting point. Introduce the reference with a clean signal. The closest prior art is. Then summarize what it actually teaches. It discloses. Be specific. Features, configurations, and conditions. Next, mark the gap, but lacks or does not teach. This contrast sets up the rest of your argument. Example: the closest prior art is Smith et al. It discloses a sensor array with adaptive thresholds, but lacks temperature compensation under dynamic loads. Avoid value judgments. Stick to verifiable facts so the examiner can agree on the baseline. Now draw a clear line between the art and your claim. Focus on technical differences, not branding or user delight. Use firm signposts. In contrast, the claimed invention comprises, followed by the exact elements, parameters, or control logic. Then tighten it with, specifically it differs in that. Example: in contrast, the claimed invention comprises a temperature-compensated bias circuit controlled by a feedback loop. Specifically, it differs in that the compensation coefficient is updated per sampling cycle. Keep everything anchored to claim language. The goal: a concise, checkable list of features that the prior art doesn't disclose. Derive the problem from the differences and their technical consequences. Do not sneak in your solution. Use neutral framing. The objective technical problem is, or there is a need to. Example: the objective technical problem is to maintain stable thresholding accuracy across varying temperatures and dynamic loads. This ties directly to your distinguishing features without naming them. Avoid phrases like, by using our compensation loop. The problem should be solvable in multiple ways in theory. That's what makes it an objective, fair starting point for assessing inventive step. Connect the distinguishing features to a measurable outcome. Use "this results in" to express causality, then quantify when possible. Example: this results in threshold drift below 0.2% across 0 to 80 degrees Celsius. Back it with support. Experimental data demonstrate, or modeling indicates. Reference test conditions, datasets, or mechanisms that explain why the effect occurs. Example: experimental data demonstrate a 15% latency reduction under load, consistent with the predicted feedback dynamics. Clear link, credible evidence. This step turns a difference into a technical effect, which anchors the inventive step analysis. Show why a skilled person wouldn't reach your solution easily. Point to missing motivation, conflicting teachings or trade-offs. Use phrases like, the prior art gives no incentive to combine features, change parameters, or apply a mechanism. Or, the skilled person would not adopt this approach due to expected instability, complexity, or cost. Example: the prior art gives no incentive to update the compensation coefficient per sampling cycle. It teaches fixed calibration to avoid noise amplification. If a reference teaches a way, highlight it. Explain why common combinations still wouldn't yield your specific configuration and effect. Aim for statements that are neutral and testable. Replace vague claims with numbers, conditions, and methods. Swap improves performance for reduces latency by 15% at 80% CPU load, or cuts threshold drift to 0.2% across 0 to 80 degrees Celsius. Avoid adjectives like revolutionary, robust, or significant unless you define them. Use hedging when appropriate. Under the tested conditions, within the specified range. This precision builds credibility and keeps your claims aligned with evidence. Examiners reward clarity, not hype. Use this PSA flow every time. Art right pointing arrow, differences right pointing arrow problem, right pointing arrow effect, right pointing arrow non-obviousness. Add signposts so the reader never gets lost. First, the closest prior art is. Next, the invention differs in that. Therefore, the objective technical problem is. This results in the skilled person would not. Keep the through line tight. Every sentence should connect the problem to the effect via the claimed features. That traceable logic is your strongest persuasive tool. Practice with one claim today, and refine your evidence to match each step.